Okay, tonight's homework had us kind of look at pH. So a few things before we start this is we need to know our basic equation. So we need to know that pH is the negative log of H3O plus. We also need to know that pOH is the negative log of OH minus. We need to know that based upon the autoionization of water, which is this, then we know that K is equal to H3O plus times concentration of OH minus, which we said was all equal to 1 times 10 to the negative 14th. So this is the important part to know, is that all of this is equal to that. And we can derive from that, we talked about in class, pH plus pOH is then equal to 14. Those four equations can pretty much solve almost everything. We can also take the inverse of these two equations, which means that if I want to know the H3O plus, I can do the inverse of this, which is 10 to the negative pH, and the inverse of the OH minus, which is 10 to the negative pOH. So those things can help a ton if you know how to do those. So let's just take a look at a few of these. I assigned problems 1, 2, 4, and 11. So again, remember the first thing to do is write out the balanced equation. So NaOH, when I add it to water, it becomes Na plus and OH minus. And we said that this one was 0.05 molar in problem 1a. And that meant that this one is also 0.05 molar. And they ask us to solve for the OH minus concentration in the H3O plus. So I know that the OH minus is 0.05. And the H3O plus, if I go back to a slide, I know that I can use this equation to solve for the H3O plus. So the H3O plus times the OH minus is equal to 1 times 10 to the negative 14th. And I know that this is my x, and this is my 5 times 10 to the negative second is 1 times 10 to the negative 14th. I know 2 times 5 is 10, so this will be 2 times 10 to the negative 13th is equal to x. And that is my H3O plus. And then they ask for the pH. I could solve for the pOH, is the negative log of OH minus. And this would be the negative log of 0.05, which would be a pOH of 4. Sorry, that pOH is not 4. That pOH should be 12.7. And then the pH plus the pOH is 14. So 12.7. Oh, this is wrong. Hold on a second. That pOH should be 1.3. And the pH should be 12.7. Sorry about that. That's what happens when you're in a hurry. pH plus 1.3. So the pH is 14 minus 1.3 or 12.7. The answer in your on your guide is 10 because it should only be one significant figure because of 1a. Kind of ridiculous, but that's okay. Let's take a look real quick. I'm just going to do one other one. Let's do problem number 4. So it says the pH of an NaOH solution is 12.9. And they ask us for the original molarity of this. So first of all, I'm going to have to work a little bit backwards. So if this is NaOH, I know that, again, that can be separated out into Na plus and OH minus. And I do know the pH, which means that I know the pOH. If this is the pH, of 12.9, then the POH is 1.1 because they need to add up to 14. So this would be 10 to the negative 1.1, or 0.079 is the molarity, which seems right. That's approaching -2. So this is about there. And so if this is 0.079, then this is also 0.079 because this is a 1-to-1 ratio. Let's do 11 just for kicks. Actually, let's do 1B real quick. So it says sulfuric acid, H2SO4. I'm mixing that with water. It's going to make H3O plus and SO4 2 minus. And there's going to be 2 of these for every 2 of these because I got to take care of both of those H pluses. So they tell us that this starts off as 2.5 times 10 to the negative third, which makes this 5 times 10 to the negative third because of the 1-to-2 ratio. And then if I do the pH, I'm going to do pH is equal to the negative log of 5 times 10 to the negative third. And on a number line that would be in between, that would be straight dab in the middle of 10 to the negative third and 10 to the negative second. Because if I got this to 10 times 10 to the negative third, that would equal 10 to the negative second. So it's approaching that. So I should have a number between 2 and 3. And we do. We actually end up with a pH of 2.3. And I can go backwards and calculate my POH. So that would be 11.7. And 10 to the negative 11.7 is the OH minus concentration. And if I do that on a calculator, I should get an answer of 10 to the negative 12th, but some number times it. So this is 1.99 times 10 to the negative 12th for the OH minus. Okay, I hope that helped. I'll see you tomorrow in class. Quiz tomorrow.